Hello friends, I am Shivaji Sonone. Welcome to the class of physics. In this video, we'll see the types of solid and the concept of semiconductor. This video consists of the different concept, energy band diagram in solid, metal, semiconductor and the insulator, types of semiconductors, doping in the semiconductor, carrier concentration in the semiconductor, as well as the distinguish between intrinsic, extrinsic type of semiconductor, difference between semiconductor and the metal, conductivity of the semiconductor. The formation of energy band diagrams in the solid. So see here, these are the different energy levels due to the electrons. According to the Bohr's atomic models, electrons are revolved around the nucleus in an atom, and in isolated atom, the electrons are orbiting around the nucleus with certain energy levels. When these isolated atoms are get brought together to form the solid, various interactions occurs between the neighboring atoms due to the force of attraction and the repulsion force. At the equilibrium position, the forces attractive force and repulsive force of that atom get balanced, and the potential energy of the system becomes minimum. Due to this, the energy of the electron will not be same. So energy of this electron is get different. And due to this neighboring atoms, the energy of this electron due to the presence of atoms get changed. And it consists of number of energy levels, and it is known as energy bands. So in the solid, there are two types of energy bands. One is known as valence band and second one is known as conduction band. So the electrical property of any material, it depends upon the valence electrons, and the energy band diagram of this valence electrons is known as valence band. Then the energy bands which is corresponds to the free electrons is known as conduction band. And the band gap or the separation between conduction band and valence band is known as energy band gap. So depending upon this energy band gap, the solid is get classified into the three types, that is metal, insulator and the semiconductor. The energy band diagram for the metal or the conductor is nearly equal to 0, or this energy band gap for the semiconductor is less than 3 electron volt, and for the insulator it is greater than 3 electron volt. So this is the first one, that is the metal. In case of metal, the first possible energy band diagram shows The conduction band is only partially filled with the electrons. With a little extra energy, these electrons easily get transmit into the higher energy levels, or it is in the conduction bands. In case of second energy diagram, it consists of valence band and the conduction band which overlap on each other. This is because the lowest energy level in the conduction band needs less energy than the highest energy level in the valence band. So the electron in the valence band is overflow and it is in the conduction band. So these are free to move about the crystal for the conduction. So due to these free electrons, current is easily flows through the conductor through the metal. The highest energy level in the conduction band occupy the electron in the crystal at the absolute zero temperature, and this is known as Fermi level. And the energy correspond to this highest energy level, Fermi level, is known as Fermi energy. If the electron get enough energy to go beyond this energy level, then conduction it takes place and current is going through the metal. This kind of type of the solid is known as semiconductor. So what is the semiconductor? In the semiconductor, at absolute zero temperature, no electron has energy to jump from valence band to the conduction band. So at absolute zero temperature, this semiconductor is like as a insulator. At the room temperature, some valence electrons get the energy due to this thermal energy, and these electrons are moved in the conduction band and conduct small amount of current. In the semiconductor, this is the motion of electron from valence band to conduction band due to the thermal energy. The band gap in the semiconductor is very small. So fraction, that is the amount of electrons, is directly proportional to the e raised to power or e raised to negative power of energy band gap per kBt. This is kb. Kb is the Boltzmann constant and T is the absolute temperature. So this band gap is very small in case of semiconductor. As the electron leave the valence band due to this thermal energy, then it leaves some energy levels in band as unfilled, and such unfilled regions are known as holes in the valence band. And it is these holes are also known as positive charge carriers. Any movement of this region is referred as a positive hole from one position to the another position. So the conductivity of this semiconductor is in between 10 raised to power 4 to 10 raised to minus 6 Siemens per meter inverse. The conductivity of the semiconductor is in between metal and insulator. Third type of solid is known as insulator. In case of this insulator, electrons cannot jump from valence band to the conduction band, and it is due to the large band gap. So therefore, the conduction is not possible in case of insulator. This energy gap for the insulator is greater than 3 electron volt. For example, this band gap, energy gap for the diamond is 7 electron volt. So diamond is the bad conductor. Then to understand the next part, you have to know the concept of electrons and holes. When some energy is supplied to the electron, then this electron moves from valence band to the conduction band by breaking the bonds. While coming out from the valence band, it leaves behind this vacancy, and obviously it is known as holes. An electron from the neighboring atom break away and come to the place of missing electron and complete the covalent bond. Creating at the same time, it create another hole at the another place. Holes move randomly in the crystal, and the completion of this bond may be necessary due to the electron from the bond of neighboring atom. So this is the part of insulator. Then next one, we'll see the concept of types of semiconductor. There are two types of semiconductor, one intrinsic type of semiconductor and extrinsic type of semiconductor. So intrinsic type of semiconductor. What is the intrinsic type of semiconductor? When the semiconductor is completely pure form, is known as intrinsic type of semiconductor. For example, silicon and germanium. Silicon and germanium are the intrinsic type of semiconductor. In silicon and germanium, there are four valence electrons. So these type of semiconductor are known as tetravalent element. So in this case, these germanium, see the diagram. In this case, this one germanium atom is get bond with another neighbor four covalent four germanium atoms by sharing these four electrons. So each germanium atoms consist of four valence electrons, and there is a covalent bond between neighbor germanium atoms, and there is a one valence electrons, and this valence electrons and the holes when get combined with another atoms, then this intrinsic type of semiconductor convert into the extrinsic type of semiconductor. So energy gap in silicon is 1.1 electron volt, and for the germanium it is 0.7 electron volts. So this is the silicon. The atomic number of the silicon is 14. Electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p2. So in the outermost shell there are 4 electrons. Similarly, for the germanium, atomic number is equal to 32, and the valence electrons in this outermost shell 4s2 and 4p2. Both silicon and germanium are intrinsic type of semiconductor, and in its outermost shell there are 4 electrons. Next one, in the intrinsic type of semiconductor, number of holes and number of electrons are equal. The quantity of these holes and the electrons is same. Then the next concept, that is the doping of the semiconductor. What is meant by doping of the semiconductor? When some impurity, small amount of impurity is add into the pure semiconductor, then this is known as doping, and these impurity atoms are called as dopant. Depending upon the type of impurity, there is a classification of doping into two types, P type of semiconductor and N type of semiconductor. And this semiconductor is known as extrinsic type of semiconductor. Means this is impure semiconductor. There are different methods of the doping, hitting the crystal in the presence of dopant atoms. Second one, adding impurity atoms in the molten state of semiconductor. Third possible methods, bombarding semiconductor by the ions of impurity atoms. Then we'll see the extrinsic type of semiconductor, which is impure form. And this extrinsic type of semiconductor get classified into the two types, N type of semiconductor and P type of semiconductor. First one, N type of semiconductor. In the N type of semiconductor, when the pentavalent element is doped with the pure semiconductor, then this type of semiconductor is known as N type of semiconductor. When the semiconductor of fourth group, that is the silicon and germanium, is doped with pentavalent, for example, phosphorus, arsenic, and antimony, then the P type of semiconductor is get formed. When you consider the example, germanium is doped with the arsenic element, the four valence electron of the arsenic form the covalent bond with four germanium atoms. And the fifth electron is loosely bound. This is the fifth electron. This is the arsenic atom. And this arsenic atom forms the four covalent bonds with the four germanium atoms. And one electron is free. So it is loosely bound with the crystal. And energy required to remove, to detach this fifth electron is very small. For the germanium, it is in order of 0.045 electron hole. So this free electron is easily available for the conduction. When small amount of energy is supplied due to the thermal energy also, so this electron is get detached and it is ready to conduct the current. So force of attraction between this mobile electron and the positively charged impurity is very weak. Such electrons from the impurity atoms will have energies slightly less than the energy of the electron in the conduction band. Therefore, the energy state corresponding to the fifth electron, is to be forbidden gap and slightly below the lower energy of the conduction band. So this energy is called as donor level. So impurity atoms is called as donor. So N type of semiconductor is also called as donor type of semiconductor. Second type of extrinsic type of semiconductor is P type of semiconductor. When intrinsic semiconductor is doped with donor impurity, not only does the number of electrons increases, but also the number of holes also get decrease. And due to this, the number of holes decreases and number of electrons get increases. So in the N type of semiconductor, the number of electrons increases and number of holes get decreases, means the majority carriers are electrons and minority carriers are holes. If N and P represent the electron and hole concentration, in the intrinsic type, this type of or this number of electron holes is same, But when doping takes place, the number of electrons in the N type of semiconductor is maximum. And when the concentration of electron is increases above the intrinsic value by the addition of this donor impurity, the concentration of the whole falls below the intrinsic value. And then making this product NP, which is constant, equal to the electron square, means this number of electrons get increases. Then the second type of extrinsic type of semiconductor is the P type of semiconductor. In the P type of semiconductor, when trivalent element, when the trivalent element is get doped with tetravalent element, then this type of semiconductor is known as P type of semiconductor. So in this case here, in case of this P type of semiconductor, when this tetravalent element like a silicon and germanium is get doped with indium, boron or this gallium, then the resultant semiconductor is known as P type of semiconductor. When you consider the one example, germanium is get doped with the indium. This in the outermost shell of this indium, there are 3 electrons. So these 3 electrons get recombined with the 3 electrons of these germanium atoms by with the covalent bond. Then one the hole which is delivered create may be filled with electron from the neighboring atom, create the hole in the position when electron is get jumped. And due to this, the number of holes is get increases. So this trivalent impurity is called as acceptor. And in the acceptor, impurity produce energy level which is just above the valence band. And this dopant or this impurity is known as acceptor. Then the energy difference between acceptor energy levels and top of the valence band is very small than the band gap. And this P type of semiconductor is also known as acceptor type of semiconductor. So in the P type of semiconductor, the majority carriers are holes and minority carriers are electrons. So we get the majority carriers, the product is equal to pi square. So the number of holes are maximum. To distinguish between intrinsic and extrinsic type of semiconductor, we understand the actual difference. This intrinsic types of semiconductor is pure semiconductor and it is the pure tetravalent element. Extrinsic type of semiconductor is from in this type of semiconductor, group third and group fifth element are doped in the group fourth element. The conductivity is only slightly or very small, but the conductivity of this extrinsic type of semiconductor is get increases due to the increasing majority carriers. Conductivity of intrinsic type of semiconductor increases with increasing temperature. Conductivity depends upon its the amount of impurity added. It depends upon the doping for the extrinsic type of semiconductor. The number of holes and number of electrons are equal in the intrinsic. But in case of extrinsic type of semiconductor, number of electron is greater than the number of holes in N type, and number of holes is greater than the number of electrons in the P type. So this is the actual difference between intrinsic and extrinsic type of semiconductor. We'll see another one, distinguish between semiconductor and the metal. Semiconductor is behave like as an insulator at 0 degrees Celsius. Its conductivity increase with rising temperature. Then in case of metal, conductivity decreases with rise in temperature. Exactly opposite case. In semiconductor, conductivity increases with respect to temperature. In metal, conductivity decreases with respect to increasing temperature. Conductivity increase with rise in potential difference applied across the semiconductor. Conductivity it is the intrinsic property of the metal and it is independent of applied potential difference. This semiconductor does not obey Ohm's law, or it partially obeys, but this metal obeys Ohm's law. V is equal to IR. Doping the semiconductor with impurity increase the conductivity. Making alloy with another metal decrease the conductivity. So this is the difference between semiconductor and the metal. Another one concept which is very important to understand this semiconductor known as electrical conductivity. So this electrical conductivity which depends upon the number of carriers. The total current through the semiconductor is the algebraic sum of current due to the motion of electrons and current due to the motion of holes. Be careful, there is one difference between metal and semiconductor. Through the metal, current is due to the motion of electrons, but in case of semiconductor, current is due to the motion of electron as well as holes also. So current or due to the electron, it is number of electrons, charge on the electron, cross-sectional area, and velocity of the electron. Similarly, for the holes, put the value of this IE and IH in the last equation. And when applied electric field is small, then semiconductor obeys the Ohm's law. So write down this I is equal to V upon R. Then put the value of this resistance according to this resistivity concept. R is equal to rho L upon R. Put the value of R, rho resistivity. This this is the L length of the conductor and A is the cross sectional area. So finally we can conclude that the conductivity is depends upon the mobility of the electrons. The electron mobility is higher than the hole mobility. This is the 1 upon rho, the resistivity, and its reciprocal is known as conductivity. Sigma is equal to. So the resistivity or the conductivity depends not only on the electron and hole density, but also on their mobilities. The mobility depends relatively weakly on the temperature. So this is the concept of electrical conductivity. The electrical conductivity of metal is greater and this insulator is very small, but the electrical conductivity of semiconductor is in between metal and insulators. So this is the part of bands in the solid, types of solid, metal, semiconductor insulator, and the type of semiconductor, intrinsic, extrinsic, and in the extrinsic, P type of semiconductor, N type of semiconductor. Thank you.